All right, so today what we're taking a look at is choosing the appropriate data display given different types of data. And you are going to want to carefully think about what type of data display you're going to choose. We have a variety of options available to us. One of the most important things is making sure that your data can actually be displayed in the data display that you've chosen. And the reason why I am mentioning this is because qualitative data in particular cannot be represented using a number of the data displays that we have available. Like, it just does not make sense to actually represent qualitative data in a number of the data displays. So if we were to look at something like an eye color chart versus the speeds on a highway, the eye color chart is quite obviously qualitative, and the speeds of vehicles on the highway would be quantitative. Now, for qualitative data, I feel like the typical choices for qualitative data that you're probably going to want to choose are, essentially speaking, pie charts for one, and also you will want to choose bar graphs. Pie charts and bar graphs both include very distinct and clear divisions between the various categories. And as a result, that's something that's going to be appropriate for qualitative data. So to give you an idea, the bar graph is going to look something like this one right here. This one actually displays quantitative data for the annual sales, although it's a misleading graph, but it does display quantitative data. And it's a good representation of a bar graph, even though it's not perfect because it's considered to be misleading by the textbook, but it does represent approximately what you'd be looking at. So whereas rather than having years down here, we'd have eye colors, and then we'd be able to measure how many are in each of those categories. So bar graphs are definitely going to work. And the other one, which was suggested on this particular problem in the example, is to use a pie chart. So the pie chart works perfectly for this one because we're just talking about percentage relative to the whole. We don't have to worry about like median or mean or anything like that because we're talking about qualitative data. Now, for our quantitative data on speeds, you saw down here that it suggested a double box and whisker plot, one on top of the other, one for interstate A and one for interstate B, all over the same number line. And that helps you compare the two sets of data, which is pretty nice. And box and whisker plot works great for this one. There are other options that you could use on something like this one, like a histogram would work fine. So the histogram, if we look at the example on another page, a histogram would look something like this one over here for the cycling thing. So you would be able to modify this so that instead of having minutes down here, we would have bins for the speed. So if you wanted to put in bins for the speed, for example, you'd probably want to go, you'd probably have like some lower limit. Like, I don't know, if we're talking about in the highway data, it might be like 45 miles an hour, everything below 45, and then 45 to 50, 50 to 55, or I should say rather 51. It would be everything below 45, and then 45 to 49, 50 to 54, 55 to 59, 60 to 64, and so on. So it would be appropriate to use bins like that, and then you would put each individual data point from the example that was given into those bins based upon where they fell. So 71, for example, would be in a 70 to 74 bin, for example. And then that would give you an idea of how many drivers are in each of the ranges of values, each of those bins in our histogram. And that's a pretty good option for that one, in addition to the box and whisker plot that was shown. And you'd have to make it a double histogram in order to properly delineate between interstate A and interstate B. Now, there are a number of other options that are available to us, and let's look at some of these examples. So if we're looking at the World Cup men's team and women's team winners, the histogram would work fine on this one. Another option that would potentially work would, the histogram would not probably be the best option, at least for one of them, because you could do everything below a certain number and everything above a certain number, and then have a couple of bins. The ones I was imagining would be everything below 20, and then one group would be 20 to 24. The next group would be 25 to 29, and then you would have above 30. And that would probably give you the best number of bins. 4 is a little low, but I think it would still end up being pretty good. Now, the other option suggested by the textbook on this one is to use a box and whisker plot again, a double box and whisker plot, which I think might be preferable. I think it would that one would work pretty well. So it would give you an idea of the range as well as the length of the whiskers and give you a really good example of the data set. And we can use both of these options because ages are quantitative. Now, if we look at number 14, for example, this is another quantitative thing. It's precipitation in inches. But unlike this one down here, which has many, many data points, we only have 12 here, and they're for particular months. So the best choice on this one, we have a couple of options. One of them would be to use a bar graph. And a bar graph is actually pretty flexible because it works pretty well for both quantitative and qualitative data. Since the data values we have are for individual months, and since we only have one of those months or one measurement for each month, it would make sense to use a bar graph for this one. So you can easily compare the months against each other and to see the overall trend over the course of the year. The other option is to use a line graph. So we can see these two graphs on the next page if it wants to load for me. So a line graph would look like this company growth run, and the box graph is like the annual sales thing over here. And in fact, when I looked up climate data for Wenatchee, you can see that it actually uses both the line graph and the bar graph on the same thing. So the precipitation data is in our bar graph, and the blue and red lines represent the high and low averages for each month of the year. So this works pretty nice, especially when we have time on our x-axis, in particular for discrete categories like months. All right, if we were to look at our next example, number 15. Number 15 presents an interesting option. It really nicely lends itself to the histogram because it includes obvious bins that you can put the numbers in, which are A, B, C, D, and F. So that's one great option for this one. The other one is actually use a stem and leaf plot. And the stem and leaf plot, I don't know if we have an example. Let's just search up a stem and leaf plot. The stem and leaf plot, I grant it as an example, but honestly, stem and leaf plots are basically just histograms. They provide a little bit more information than histograms because you can actually see the individual data points. For example, if we look at this one, we have 70, 75, 78, 78, 78. Those are all of our individual data points with our stem and our leaf. So the histogram, I personally think it looks nicer, although it is extraordinarily similar to the stem and leaf plot. So that's another great option for you on the test scores. The colors of cars that drive by your house, this one is pretty straightforward in that you would want to choose something like a pie chart on this one, because the pie chart just is a great option of representing this. A bar graph would also do a solid option on this one, because on the x-axis, we would have the various colors of the cars, and then we would count them up on the y-axis. So either of those options would work super well for those. Maybe you can consider some other options which might work well on these, but that gives you an idea of how we can choose different data representations and some data representations that are good options given different types of data.